Number 17 and 18 are asking different questions, but the work involved is very similar. So let's look at 17. Let's do B. It says, given one of the zeros below, find the other two zeros. Now, this is not really necessary. Well, it will be later in the problem, but I just want to list right away. If x equals -3 is a 0, then x plus 3 is a factor of f of x, and we'll use that at a later stage in the problem. Okay, so if we know one of those zeros or one of the factors, we can use synthetic division to try to find the other factor and then eventually the other zeros. Okay, so remember we're going to put the -3 in the box, what the actual zero value is. We're going to pull down all the coefficients from this polynomial. Careful with your plus or minus signs. If we were missing any terms in there, like let's say we didn't have an x squared, remember we would need to put a 0 as a placeholder. Leave a little space, draw your line below. We're going to drop the 1, and then we multiply, add until we get to the end. So I'm doing -3 times 1. I'm adding those, and then I just repeat until I get to the end here. I get 0. So first of all, this does confirm that -3 is a 0. The other thing that it does is it shows me what one of the other factors of f of x is. Let's rewrite f of x as the product of this original factor that we had times, remember these numbers are the coefficients of our other factor, and we've got to reduce the power by 1. So we started with an x cubed, so now we've got x squared minus 7x plus 18. What we're trying to do is find the other two zeros. So at this point, we would set it equal to 0, set each factor equal to 0. We already know this x plus 3 equals 0 gave us x equals -3. But when we set this quadratic factor equal to 0, we're going to solve either by factoring or using the quadratic formula or completing the square. Now, if you try to factor that one, because of the way the plus and minus signs are, there are not two nice, clean whole numbers that multiply to +18 add to -7. You might be thinking 9 and 2, but the signs do not work out correctly. So then we go to the quadratic formula. So remember, A is 1 in this case, B is -7, C is 18. You can hear me sing? Here we go. X equals -b. It's already negative, make it positive. Plus or minus the square root of b squared minus 4ac all over 2a. Oops. 2 times 1. Erase. Erase for me. There we go. Okay. Now that radicand, all the stuff under the square root, turns into a -23. So we are looking at, let's see how we want to simplify this. 7/2, so 3.5, plus or minus. You can put the square root of 23. Let me write it like this. Just pause and look at that for a second. So I'm pulling that negative out. That becomes the I. This can just go in the calculator. So we'll say it's 3.5 plus or minus 2.3979i. And remember, that is two solutions, 3.5 plus that number, 3.5 minus that number. Those are two complex zeros. Remember, those would not be x-intercepts on the graph. We would only see it intersecting at -3. Now, 18, similar work, just slightly different question that they're asking here. I think this is actually the easier one. So they want to know, is x minus 2 a factor of f of x? And we'll just do b here. Okay, so remember, if x minus 2 is a factor, that means we want to know, is x equals to a 0? That's the question that we're answering. So we put 2 in the box. Now, notice I'm missing a squared term. There's 0x squareds here, so I'm going to make sure I throw a 0 in there. So I go to 3, -6, 0, -5, 10. Now I can do synthetic division. I'm going to drop that 3, and then I'm going to multiply, add, and repeat the process. So that's a 6. Just work through here. Okay, because we get 0 as our last value here, that is the remainder. That means x equals 2 is a 0. That also means that, yes, x minus 2 is a factor. When we divided f of x by x minus 2, it had a remainder of 0.